Hi guys, so this lesson today is the third lesson in our trig graphs topic, and it's example 3 we're going to look at, which is actually making the sketches of the trig graphs ourselves using when we know the equation. So identifying what is the amplitude, therefore what is the maximum and minimum of the curve, and what is the period, how many times will this graph repeat itself. And we're always drawing our graphs within the range of 0 to 360 degrees on the x-axis. Okay, now really important thing to do, and this is a skill that actually carries over to higher maths as well, sketching trig graphs, is, and I want you to write this down at the side, it's really, really important to note that we are going to draw the curve, or draw the shape first. So we're going to identify the shape of the curve, i.e. is it a sine, is it a cosine, how many waves are we wanting within our range, approximately how high up and down does it go. We're going to draw that shape first, and then we're going to fit the numbers to match the kind of reference points after that, okay? And that will make more sense when I actually do some examples of what I mean, because if you mark on those sort of reference points 0, 90, 180, 270, and then try and fit the curve to match up with those points, it often doesn't look very neat, it doesn't look very accurate. So it's much easier to draw the shape nicely first and then fit the numbers on after it. So anytime we are asked to sketch a trigonometric graph, we have to draw a set of axes if they aren't already there. So we have a vertical axis, which should be in black. We have our vertical y-axis, and as you've seen in kind of the questions, we're not really interested in anything left of the y-axis. So draw your kind of graph to look a bit like this, where we have, we're only really interested in right hand side of the y-axis, really. We're not really interested left of it. Okay, so you obviously need a ruler for this, please, to draw some your nice neat axes, but the curve, you don't use a ruler because it should be a curve. So this is the y-axis, this is the x-axis, and we can see it starts at 0 here. Okay, so let's look at the equation now. Okay, so we've got y equals 2 sine x. Now the 2 is in front of the sine, in front of the trig function. That means it is the amplitude which affects the maximum and the minimum values. Okay, so amplitude of 2, I'm going to write at the side, amplitude A is 2, which therefore means the max value goes up to 2 and the minimum value goes down to -2. And that is hopefully straightforward. Don't need to explain that, hopefully. So the middle value is the number in between the trig function and the x, which is, the number isn't appearing there, that's because it's a 1. So b equals 1, that means 1 wave in 360. Okay, and when you get more experience drawing these, you don't need to write this bit really, you can just go straight to the curve, but initially we'll just draw that to keep ourselves right. So I've got 1 full wave in 3, it's a sine wave, so that means it starts at 0, goes up to its maximum, comes back down to the x-axis, goes down to its minimum, and then is going to finish in 360 on the x-axis. So I'm going to draw the shape first, and then I'm going to fit on the numbers. So it's starting at 0, it's going up to its maximum, it's coming back through the x-axis, going down to its minimum, and then finishing there. Now I know my maximum and minimum values, I want to be 2 on the y-axis there and -2 down the bottom, so I can put those on just approximately, and I should have an understanding of my x axis numbers at these points. So the maximum in the sine curve of sine x occurs at x equals 90, so put 90 there. It comes back through the x-axis at x equals 180. It has a minimum at 270, and then it comes back to finish 1 full wave at 360. So there, I've marked on my numbers, I've got the right nice shape of the curve, and that's me finished that one. Okay, so let's now look at y equals cosine of 3x. So this time the amplitude is not affected, it's not been moved, stretched vertically or compressed. It's the number of waves in 360 that is going to be affected here. So let's start by drawing the axis the same as before. Okay, so again, if you want to the side, you can kind of write these things down that the number in front of the cosine curve is 1. So a is 1, so therefore that means it has a max of 1 and a minimum of -1. And b is 3, which means there are 3 waves in 360. And it may help in this case to identify what the period of the graph is. So the period of the graph is how many degrees it takes for the graph to repeat itself, which remember is 360 divided by whatever the value of b is. So 360 divided by 3, so the graph will repeat every 120. And we're going to need to mark that onto our x-axis this time. We're not going to use 90, 180, 270, 360. We're actually going to use 120 to show where the graph repeats itself. So it's the cosine graph, which means we can now draw it. So it starts up at its maximum, it's going to go down to its minimum and come back to its maximum. But I need to be able to fit 3 curves and have them as accurately and look, the same as accurately as possible. So I need 3 of these on this graph. They need to try and be exactly kind of the same height, each of the 3, and exactly the same sort of width as accurately as you can. So draw the shape first, and then we'll fit the numbers to match. So comes down to its minimum, back up. There's 1. There's 2. And there's 3. Okay, so I'm doing this at home, so not the most accurate. I could have been probably much more accurate. Hopefully you'll be a bit more, draw yours a bit more kind of accurately. But fundamentally, they've got roughly this, approximately the same height, approximately the same width. The maximum and minimum values I can now mark on to be 1 and -1. And the period of the graph is 120, so I don't need all the intermittent kind of angles, but I can mark on that where this graph one wave finishes, which is up at the top here, and I can do a wee dotted line. That's going to be 120 degrees. There's then another full wave, which would be 240 degrees, and then it finishes 120 degrees later at 360 degrees. And that's the information I need on that graph to get the marks this time. Okay, so hopefully you're okay with that. We'll look at the next example, which is where we have y equals 3 cosine 2x. So again, we've got the cosine curve, and this time there's 2 things that are affected. There's the amplitude and the period is affected. So we'll work through it. We'll draw our axes, same as before. Okay, so we are, just drawing this axis here. Okay, information this time, the amplitude is 3, so A is 3, meaning we will have a maximum of 3 and a minimum of -3. B has a value of 2, meaning there are 2 waves in 360. So there are 2 waves in 360 degrees. So the period of the graph, as I say, by this point, it's hopefully, fairly obvious what the period of the graph is. It's half, or 360 divided by 2. So that graph is going to repeat itself every 180 degrees. Okay, so I've got 2 cosine curves and it's gone up to 3 and down to -3. So back to my graph, start at the top, remember, for cosine, start at the maximum, down, back up, that's one wave, down, and that's the end of the second wave. Okay, so the maximum is going to be 3, minimum is going to be -3, and it repeats itself there every 180 degrees. So I can mark on that that's 180, and that my final second wave finishes at 360. Last one is when we have a negative number for our amplitude. So that's going to, remember, basically flip the graph upside down, and we'll have a look at what that looks like. So draw your axis, please. Right, so A is -3. Which means it's kind of funny how it works. So the maximum is still a 3, the minimum is still a -3. It just is going to meet those in the opposite order from the usual curve. So the maximum is still 3, the minimum is still -3. We can't have like a maximum of -3, that doesn't make sense. The maximum is still the +3, the minimum is still the -3. It just, the curve is just going to be basically flipped upside down. So the period of this graph is 1, b equals 1, so there's just one wave in 360. Okay, so all this example is doing is kind of highlighting what happens when we have that -3. So it's a sine curve, so we're starting at 0. We're going to go, rather than going up to its maximum, we're going to go down to its minimum, back to the x-axis, up to the maximum, and return to the x-axis to finish one full wave. So okay, there's your sine curve. Try and draw it as accurately as possible. And we're going down to -3 and up to 3, one full wave in 360. So you can mark on your kind of points here, 180 degrees, 360 degrees, and that's you finished. Okay, so you should now hopefully be feeling confident with kind of amplitude, the period, and how they look in the equation and how to graph them. So I want you to now please work through question 3 on page 30, just the next question from the same exercise we've been working on. So we're doing, if I write that down, it's the Unit 3 booklet. It's page 30, question 3. So it's just a number of equations that you have to please graph. So draw your own set of axes with your ruler. What is the amplitude? Therefore, what's the maximum and the minimum? What is the value of B? Therefore, how many waves are there in 360? If you need to identify the period and write that all down, then please do that. Okay, so Unit 3, page 30, question 3 is your task now.